So hi everyone. In the last video on this Bell 206L4 crash, I went through a lot of analysis of both the yaw, where we saw a terrific rate of yaw happening between zero point 0.4 and zero point 0.8 seconds, and a few like acoustic analysis where we captured rotor orders and things of that kind. Now I went a little beyond that, and in this video which I'm going to present now, I used something called scalograms, which I just briefly mentioned in a few videos earlier. And these scalograms very clearly point to the tail rotor seizure in this Bell 206L4 crash. So this is going to be a very short video compared to the other ones. Let's see what I have actually got out here. So if you look at my previous video, I just picked up this region, where there's a short kind of sharp burst here, and I asked a question, what's happened here, and then I went to all the analysis there. You can go back and look at it, the yaw analysis, the acoustic analysis, and they clearly showed that there was a sequence of two events happening, one the tension side and compression side, kind of bangs that people heard. But then you look at the region preceding this kind of very placid region, which hardly seems to show any response. But you would be surprised to know that this is not quite as placid as it seems in this graph here. And why this is just let's see why. So first, some numbers out here. These are from the Google Gemini search, using a lot of documents in the public domain. It's gone through a search and brought out these numbers out here. I just wanted to, of course, focus on that one large number you see, the 42.5 hertz. This happens to be the frequency of the spin of the tail rotor. And this gets multiplied by 2 because its tail rotor happens to be a two-bladed rotor. So that would be the blade passing frequency. That will be about 85 hertz. So just have this number in mind, because we are going to come back, hit this number in a while. All right. So let me cut straight to the point here. I did a lot of scalogram analysis using Morlet wave decomposition, and I'm just showing you one of the scalograms out here. This little golf club-like thing that you see here, that's the blade passing frequency you see at around 85 hertz. That is 2 times 42.5, the number I just mentioned a few seconds back. And you see it's very intense in the 85 hertz region. So what does this possibly mean? Well, by itself it doesn't mean a lot, because it means certainly something happened to a single blade. But what exactly happened? Let's go a little beyond this. So if I look at the same scalogram now stretched out up to say 0.6 seconds, rather than just a very narrow window from 0.34 seconds, you kind of there's the blade passing frequency again at 85 hertz, but you see kind of isolated sharp streak in which this kind of phenomenon is happening. So this isolated sharp streak, well, you might dismiss it as just a casual kind of character of the event that happened there, but I think there's a lot to really look at it in a very close sense, and that's what I'm going to do now. And that's really what I call the anatomy of this streak. So here's the streak again, and what I'm trying to point out is this thing that is a nearly vertical, near instantaneous growth of frequency from the 85 hertz onwards. It's going almost vertically up. And now why would that some kind of thing happen? That would happen if there was a kind of rapid stiffening from the blade seizure. So it means that the tail rotor ceased. And so the 85 hertz climbed all the way up to nearly the second order. It's in fact the second order, that's about 170 hertz, is where it seems to have got coalesced with that 170 hertz frequency and just past the 85 hertz. So that's somewhere around 25 milliseconds from the 85 hertz occurrence. Both these facts suggest obviously that there was a kind of seizure happening in the tail rotor that caused this 85 hertz to really climb up, because of seizure in terms of frequency, because a seizure would mean a stiffening of things. So that would mean obviously in terms of modal character, that would mean a rise in the frequency, eigenvalue there, and that got all the way up to the second order there, 170 hertz, where it again kind of shows a red kind of high amplitude there. Now there's one obvious question that I had to ask myself this, and of course you might ask the same question too. Could it have been kind of impact on a blade of the tail rotor? Well, the answer is clearly no, because an impact would not result in this kind of a sharp, near instantaneous frequency rise we see on that scalogram. In fact, an impact might fragment, it might cause very high frequencies to occur, but certainly not leading from 85 hertz. It might occur far beyond, maybe thousands of hertz beyond this. That's probably because the fragment of the blade that's really left on impact would be very, very small, and you would have expect a high frequency with that small segment. That you don't see anything that happen here. Rather, you see a clean climb of 85 hertz on up to nearly 170 hertz. So this is not a case of impact. So that's all that is there here. So the final conclusion is ipsa loquitur, as they call it in legal terms, is just a tail rotor seizure. Thanks.